So now what we need to do is create the dashboard project. And we can do that from the File menu by choosing New and choosing the FRC Dashboard project from the selection box. If we do that, we can specify the project name, the project location, click Finish, and it will automatically create the project we need. It's important to note that you're creating two projects for this application. One is the robot project, and the dashboard project is separate. Remember that all of the code within the robot project executes underneath the CRIO target, while all the code on the dashboard project runs underneath my computer. So let's open up the dashboard main VI, and what we see when we do that is a pre-created dashboard project which shows us the camera image, the values of analog inputs, values of PWM and digital outputs for both slot 4 and slot 6, solenoid output, battery level, and communication information, as well as some match information, error messages, and user data. I'm going to just recommend you make two modifications to this VI. First, right-click on the icon of the VI and choose VI Properties. You may have noticed that the VI is set to be a certain size. If you choose Window Size and adjust the minimum panel size to be something much smaller, say even 800 by 600, then that will allow you to resize this project to fit a laptop screen which may not have as high resolution as necessary to show this whole thing at once. The second modification I would recommend is again to access VI Properties by right-clicking on the icon, choose Window Appearance, and then customize this appearance. If you were to run it right now, you'd notice that the scroll bars are disabled. Again, if you have a small or a low-resolution laptop screen, you may want to enable the scroll bars so that it's possible to navigate within the VI even while it's running. So we'll activate both the vertical and the horizontal scroll bars. So now that we've made some modifications to the front panel, let's take a quick look at the block diagram. If we were to take a look at this code, we see that there's fundamentally two parallel loops. The top one is receiving camera images from the robot, and the bottom one is receiving status data from the driver station. This is the code that we're going to need to slightly modify to display the custom data we've put into the dashboard data. And if you scroll down a little bit further, you see that there's code which is loading a team logo from either a PNG or a JPEG file in the same location as this VI and displaying it on a picture indicator on the front panel. If we just double click on this, you'll see where that is. It's right here. We return to the block diagram. We see underneath there's also some information being displayed about whether there's a problem with the IP address. So again, most of this code you should not change. We're only going to focus on what we need to modify in order to display this custom information. In the very center of the status receive is this function here. If we activate the context help, we see that this is called unflatten from string. And what it's doing is taking an array of bytes, which is being received from the robot, converting it to a string, and then converting that string into the data type specified by the wire in the top middle of this function. The output of this function matches exactly the input wired here. So what this function is doing is interpreting the byte stream of data being sent by the robot into the appropriate data type. Well, recall what we just did on the robot side. We made a modification to the dashboard data type, and we added a few parameters from our lifter state machine. It's critically important, because we changed that data type, that we must make the appropriate change in this VI. If we follow this wire back, we see that it's actually coming from this constant over on the left. This constant, we can verify by right-clicking on the edge, is not defined to be a typedef. So what we need to do is replace this constant with the typedef that we just created in our other project. So let's go back to the project window for the dashboard project. What we're going to do is add a file. What we're going to add is the dashboard data type from the robot project we just modified. We add that, and if we click on the Files directory, expand the tree, we'll see that this is one instance where we expect to see files existing in two different directories within our LabVIEW data. So take a look at what we've got here. Here's our dashboard project, which contains all of the files which were automatically created. And here, from our robot project directory, is our dashboard data type. And notice how it also has included a reference to the lifter state enum. Recall back that that dashboard data type, we added the lifter state. And because that lifter state itself is a typedef, it has automatically linked that up and listed it in our files directory here. So everything here is as it should be. Now all we need to do is drag this dashboard data type onto our block diagram. Once we do that, and we can right-click on the edge to confirm yes, it's a typedef. And if we open that typedef, we see all of that information which we just added is there. And the nice thing is that it's now linked to the same file as the robot data type. So if we make a modification to this data type in either project, it will be reflected next time we load the opposite project. We're going to delete this constant and connect this up. Now let's take a closer look at what's happening on the other side of this unflattened from string. This is where the dashboard data is decoded, unbundled, and displayed in indicators. We return to the front panel for a moment and say, for example, we look at these PWM indicators. If we double click, we see that that cluster is here. So we don't need to change any of this information. We just need to additionally extract and display the variables we added. So take a look at this unbundle function. Look as we hover over all of these other parameters that these unbundled terminals are giving us exactly those indicators that we added. So what we can do is right click and create an indicator for each of them. You may want to do a control drag to make a bunch more space in this part of the code so that you can cleanly add all these indicators. Just repeat this process. Right click, create indicator. Right click, create indicator. And right click, create indicator. Clean up our wires a little bit. Maybe even align our terminals and distribute them. There. So now we can double click on any one of these terminals, jump to the front panel, and rearrange these indicators. Maybe we don't need the error messages to be quite so large, so let's resize that and move our 3 indicators to a more convenient location. Maybe even rearrange their labels a little bit. Then again, we can align, distribute, and now we've modified our dashboard so that we can see some custom information. So now let's return to our robot project. Go to robot main and run the VI. And once that VI is running, we can run the dashboard program and we'll see live updates of the values of the program. Right now we're seeing some error messages and a lack of images because I've got no camera connected at the moment. But what we do see is that the third PWM output is showing a negative value and our lifter state is showing moving down. So this is actually a verification that what we just set up is actually working, because our lifter mechanism, remember, is attached to PWM output 3. And if it's in the moving down, that's what we would expect our motor speed to be. I'm going to just scroll over a bit so that we can keep that information on the screen. And let's return to the robot main VI and drill down into our lifter sub VI. Remember that we've got the ability to simulate with these front panel inputs the values on this state machine. So to activate that, I'm going to just double click on my global variables to go to the simulate mode, turn it on, minimize this, and now we should be able to watch the output values of the FRC dashboard when we simulate the values in our lifter state machine. So if it's moving down, it's waiting for the lower limit switch. So when we push that, we see that it's gone to the wait for ball, and we see that the lower limit switch value has indicated. If we hit our ball sensor,